Hello physics students, welcome to the third video where we're going to recap our understanding of the equations of motion. And this is out of the sort of textbook that you're provided with, recognizing that we have motion, two types of motion that we learnt in physical science. Motion where there was a uniform velocity, and that's this case here where there's no acceleration and it's all described by V equals S on T. And the other type of motion that we had was when we had uniform acceleration. So we're only looking at the cases where the acceleration remains constant, doesn't go up and down, change. The real world is much more complicated than that, but we simplify it down into chunks that we can understand. And this is out of your textbook, recognizing that these three equations here are what sit on your information sheet, so you don't have to memorize them. A is always constant because it's uniform acceleration. This one here is one we might use occasionally, and it represents just the average. And if I asked you how do you work out the average of two numbers, you add them together and divide by 2. And so if you're given the initial and the final velocity and you're asked for the average velocity, you just add them together and divide by 2. Effectively, you've got 2 points on your motion graph. You're drawing a line between the two. Because it's a uniform acceleration, you can look at the midpoint as your average. And this is just this one down here is just combining this equation here with this one here. And so there's no tricks to that. And recognize that we would have to rearrange some of these equations depending on the scenario that we have to work with. Okay. And usual completely standard symbols. Okay, the physics information sheet doesn't tell you what the letters are. The physical science one did, which helped you, and so you do have to make it second nature that you understand that S is displacement, U is initial, all those sorts of things, and the units and how you would describe the units as well. Let's just do a couple of quick examples, and that should remind us how to do these ones. So firstly, let's do a car. It starts from rest and reaches a velocity of 60 kilometers an hour in 8 seconds. Assuming the acceleration to be constant, calculate the acceleration and the displacement in this time interval. So what we would do in our standard situation is we would circle the information that we know as we come across it. Now, a car, that's interesting, but it's not that interesting. We're physics students. We're interested in physics. And so first thing we're given is starts from rest. It then reaches a velocity of 60 kilometers an hour. Now they've very kindly converted that into meters per second, which we're going to use. Why are we going to use the meters per second instead of the kilometers per hour? Because our time here is in seconds. And so we've got V and we've got U. That gives us our magic 3. And so we can use the equations of motion. Now, hopefully you remember how to calculate or convert kilometers an hour into meters per second. The simple way I try and remember to do it is we are just converting the mathematical operation. What does 60 kilometers an hour represent? It represents 60 kilometers in 1 hour. And that gives us 60 kilometers an hour to minus 1. Now if we wanted that converted into meters per second, we do exactly the same calculation, almost. But instead of kilometers, we write our distance or displacement in meters and our time in seconds. So what's 60 kilometers in meters? There's 1,000 meters in a kilometer, so it's 60,000. What's 1 hour in seconds? 60 times by 60, and we do that calculation and we would get 16.67. Okay, that's the way I remember how to do it. And you could convert that, so that could be kilometers per minute, in which case we would convert the minute into seconds. Sometimes they like to throw out weird units just to try and confuse you, and so it's helpful if you understand how to convert those units into something you're more familiar with. Alrighty, let's get rid of that. Let's make this into a point, and see how the textbook does it. Well, first thing is they assign all the information, which is what we did, and recognizing the equation to use, the first one is A equals V minus U on T, which is just a rearrangement of V equals U plus AT, and they get the answer. And then as soon as they get A, that means there's 4 of the 5 unknowns, or the equations of motion parameters, and so you could actually work it out a variety of ways, and in this case they used S equals UT plus half AT squared. Alright, so the only tricky thing that they did there is they used this equation instead of this equation. So depends on how your mind works, whether or not you just put the numbers into this equation and then rearrange it to solve for A, or you rearrange it and recognize that this equation and this equation are the same. Let's do another example. I think a train starting from rest travels 30 meters in 6 seconds. Find the acceleration and its velocity. And of course, we are given 3 pieces of information: U, S, and T, and we've got to find A and V. So we're always giving you enough information to solve it. If you come to a question and you don't think we've given enough information to solve it, there's something wrong. And it's rarely the question. It's perhaps hidden in the question, the information that you need. Alright, so we can get rid of that. Let's get rid of that. And how do they do this one? Well, S equals UT plus half AT squared. No real tricks to that. You just put the numbers in and you get the acceleration. And again, put the numbers in and you get the acceleration. So fairly straightforward questions. Then we moved on to vertical motion and projectile motion in physical science. Vertical motion is just when you drop something and it falls under the influence of gravity. Projectile motion is a bit more complicated because we're throwing things with a horizontal velocity, and so we get a combination of horizontal and vertical motion that we then have to analyze to get the projectile motion. So a bit more complicated. And in physics we'll go a bit more complicated than that as well. So here we just have an example of dropping something. So the helicopter's hovering, and this is like a time lapse, and the point of this diagram is to show that the object is actually accelerating. How can we see that it's accelerating? We can see that it's accelerating because the distance traveled by each time interval, supposedly each time interval is the same, increases. Okay, we can see that this distance is increasing each time. So the object is getting faster and faster, so in each time interval it's traveling further and further. Alright. Now, so let's do an example of that sort of motion. In this case, a spanner is dropped from the 6th floor window and takes 2.2 seconds to hit the ground. Fortunately, no one was standing underneath. Why would you drop a spanner? Exactly. Calculate the height from which it was dropped and its impact velocity. Okay, I won't circle all the information. Can you see the 3 pieces of information that we have there? Well, actually I should have circled, because it's one of those examples where a bit of information is hidden. We have T. That's it. Where's the rest of the information? Well, if it's dropped, that tells us that U is equal to 0. Alright, that's 2 pieces of information. What's our 3rd piece of information? Well, it falls under the influence of what? Gravity. And what does gravity do? Gravity applies an acceleration of 9.81 meters per second to the minus 2. Oh, we've added another digit. In physical science, I think we were using 9.8. In physics, we can handle 2 decimal places. Alright, and so there's our 3 pieces of information. Now notice this example, for one reason or another, the textbook, being in Queensland, they try to make the maths a little bit easier, and they say the acceleration is 10. Now here in Tasmania, I think we can cope with the acceleration having 2 decimal places. I think this is a bit silly. Alright, it's not that complicated, especially when you've got a time with one decimal place. Why do they do that? They just did it. And so unfortunately these examples can be a little bit confusing. And you also find that when you do some of the questions that come from this textbook, your answer might be slightly different if you use gravity, because they'll use a -10. Oops, I should have said down there, shouldn't I? Hopefully you can still see that, and my smiling mug shot is not in the way, because gravity is always acting down. Let's get rid of that though and see what they actually came up with. And so using s equals ut plus half at squared, they put the numbers in and they got a minus value because this is a minus 9.8, and that's cool because that means it's the sixth floor is your 0 meters, and so moving down in the negative direction gives you a negative displacement. And the same with the velocity. The velocity should be a negative. Now you can get rid of those negatives and write down there, but it's a good habit to get into, being careful with your signs, because in physics we do try and trick you into using the wrong signs. How fast will a ball be travelling when it strikes the ground if it is dropped from a height of 100 meters and there is no air resistance? Again, we only seem to be given one thing, but being dropped, that means the initial velocity is 0 and it's falling under the influence of gravity, so we're given the value of g. And in this case the value of g is 9.8. Again, we can use 9.81. We're given u, s and a, so we could use v squared equals u squared plus 2as, and we put the numbers in. Now they've done this, this is a different textbook, so they do it a different way. They write in the units. Now I personally find that a little bit of a time waster, so I wouldn't necessarily put in the units until you get to the very end. However, I do like their use of brackets. Brackets are very handy because they keep your work tidy and they keep everything clear. So if you're making a mistake, if your setting out is neat and tidy, you can go back and work out where you made that mistake and not make that mistake again. If your working is all messy and you make a mistake, you may work out how you made that mistake, but you won't remember not to make that mistake again. You'll just learn how to answer that question. Alright, and so they did this, and we get this, and when we take the square root, the answer could be positive or negative, but because we used a negative acceleration and a negative displacement, okay, so there, in this case it's a little bit tricky, because they could have said the displacement, or they're saying that the displacement again is, its starting point is 0, so it's moving down, so those two negatives cancel. Otherwise you'd get a negative trying to do a square root of a negative. Now if you ever end up trying to do a square root of a negative, it means that you've mucked up your signs or you haven't got your frame of reference right, and you can sometimes change things around. And so even though the square root gives us two possible answers, obviously the answer is negative. Alright, in the next video we're going to look at going up and how that combines with going down to make motion a little bit more complicated. Cheerio!